Hi, my name is Jonathan Lambert. This talk will cover converting raw continuous quantitative data into a frequency distribution. So what we're going to cover today is the conversion or converting raw continuous quantitative data into a frequency distribution. Okay, so let's say we perform an experiment, and let's say we stop 20 people and we ask them the question, how much did they spend on over the weekend? Okay, and let's say the first person says they spent €15.16. Let's say the next person says €14.88. Let's say the next person €12.67. Let's say the next person €12.23, €15.47, €5.53, €7.21, €10.09, €17.69, €15.07, €3.86, €14.55. Let's say €6.45, €12.76, €10.78, €18.72, and let's say €2.35, €6.34, €1.28, €4.14, €14.61, €4.16, and let's say €2.53, and finally €17.12. So we asked 20 people how much did they spend over the weekend, and we ended up with 20 unique responses, or 20 responses. They didn't necessarily have to be unique. So that's raw continuous data, because money can be considered to be a continuous quantitative variable. So if I want to convert this into a frequency distribution, well, we know that frequency distribution is simply a two-column table. Okay. Down the first column is the variable of interest. In this case, well, the question was how much did you spend? So maybe we'll call the variable spend for how much money was spent over the weekend. Now, in the discrete case, what we would have done is we would have listed off all the unique values that occurred in the experiment. In this case, if we were to do that, we would have 20 unique values. Okay? So what we'll do in this case is we'll create what's known as a group frequency distribution. And with a group frequency distribution, we're going to count how many values fall within particular ranges. So to simplify things, let's assume that we have 4 classes. Let's say the first class is from 0 to 5. The next class is from 5 to 10. The next class is from 10 to 15. And the final class is from 15 to 20. So what we're interested in is how many values were between 0 and €5, how many values were between 5 and €10, how many values were between 10 and 15 and 20. In a later talk, we will cover how to calculate the optimal ranges for these particular classes. So we know that a frequency distribution is simply a two-column table. Down the first column we have the variable, okay, and down the second column we list the frequency of occurrence of that variable, f. So we can see that each class has a lower bound and it has an upper bound. In this particular instance, we see that the upper bound of the first class is the same as the lower bound of the second class. In this case, to interpret this, we're interested in how many values fall between 0 and 5, not including 5. Let's count. So how many values are between 0 and 5, but not including 5? Well, we have one value, 3.86. We have 2 values, 2.35. And we have 3 values, 1.28. And we have another value here, which is 4 values, 2.53. Sorry, there's 4.14 and 4.16, giving us a total of 6 values between 0 and 5. So we have 6 values between 0 and 5. How many values are between 5 and 10? Well, between 5 and 10, we're not going to include 10, so it's everything up to €9.99. So let's count. So we have 1 value, 2 values, 3 values, we have 4 values, and we have 4 values in total. How many values are between 10 and 15, not including 15? Well, we have 1 value, 2 values, 3 values, and we have 4 values, we have 5 values, 6 values, and we have 7 values. And have I missed anything there? We have 7 values and we have 8 values in total. 8 values there between 10 and 15. How many values are between 15 and 20? Well, all the remainder are. We have 1, 2, 3, 4, 5, and finally we have 6 values, giving us a total of 24 observations. We have 1, 2, 3, 4, and we have 1, 2, 3, 4, 5, 6, giving us 24 observations in total. So we have a total of 24 observations. So what we can see here is frequency distribution. It's a grouped frequency distribution because we have classes of variables. Yeah? Okay. The variable falls within a particular class. Between 0 and 5 euros, we can see that 6 people spent between 0 and 5 euros. Between 5 and 10 euros, we have 4 people between there. We have 8 responses between 10 and 15 euros. And finally, we have 6 responses between 15 and 20 euros, giving us a total of 24 responses. Once again, we can convert this into a relative frequency distribution by augmenting this with another column, the relative column. And to build the relative value, well, we find out how many observations relative to the total. So between 0 and 5, there are 6 observations out of the 24 observations, which gives us a fractional amount of 6 24ths. As a decimal, that represents 0.25. Between 5 and 10, there was 4 observations out of 24, so that represents 4 of the 24s, giving us, as a fraction, 0.17 rounded to 2 decimal places. Between 10 and 15, we have 8 observations, 8 out of the 24, so we have 8 out of 24, which gives us a total as a decimal of 0.33. And between 15 and 20, we have 6 observations out of the 24, so that gives us 6 of the 24, which gives us a total of 0.25, giving us a total of 1 when we sum up all the values. So that's the relative frequency. Then we can create a percentage frequency, simply by multiplying the relative frequency by 100. We've said a number of times that to convert a decimal into a percentage, we simply multiply by 100. To convert from a percentage into a decimal, we simply divide the percentage by 100. Okay, and it's important that the decimal is the relative frequency. Okay, so we have the relative frequency for 6 people that spent between 0 and 5 at 0.25. To get that as a percentage, we simply multiply by 100. 0.25 multiplied by 100 gives us 25. So what we're saying is that 25% of the data values were between 0 and 5. 0.17 is 17 when we multiply by 100. 17% of the data values were between 5 and 10. 0.33 is 33 when we multiply by 100. 33% of the data values were between 10 and 15. And finally we have 0.25, which is 25. So we have 25% of the data values were between 15 and 20, giving us a grand total of 100% for the total number of observations. So, just to reflect over this, what we've covered is converting raw continuous quantitative data into a frequency distribution. We had 24 responses to our question, how much did you spend over the weekend? You can see that the first response was 15.16, or 15 euros and 16 cents. The last response was 17 euros and 12 cents. In this case, we create a group frequency distribution with 4 classes. The first class represents how many values were between 0 and 5, there were 6. How many values were between 5 and 10 euros, there were 4. How many values between 10 and 15 euros, there was 8. How many values between 15 and 20 euros, there was 6. This is our frequency distribution now, simply our 2-column table. Then we converted it into relative frequency distribution, where we took the number of observations relative to the total. Between 0 and 5, there were 6 observations, representing 6 of the 24 observations, so it's 6 over 24. As a decimal, that is 0.25, dividing 24 into 6. Between 5 and 10, there were 4 observations, representing 4 of the 24s, so that's 4 over 24, gives us 0.17, and so on and so forth. Then what we finally did was we converted the relative frequency distribution into a percentage frequency distribution simply by multiplying the relative frequency by 100. So 0.25 multiplied by 100 gives us 25. So 25% of the observations are between 0 and 5. 17% of the observations are between 5 and 10. Multiplying 0.33 by 100 gives us 33. 33% of the observations are between 10 and 15. And finally, similarly again, 25% of the observations are between 15 and 20. Okay, I'd like to thank you for your time, and that concludes this session. Thank you.